This video demonstrates the process of creating schematic symbols for an Altera A10 GX160 672-pin FPGA device. The Altera physical flow in Part Builder from CAD Enhance brings a groundbreaking efficiency to the process. Symbols can be created for a variety of EDA schematic capture tools, including Allegro HDL and OrCAD Capture from Cadence, and DX Designer from Minter Graphics. Let's look at the structure of the FPGA device on the Altera website to see how we might want to construct the symbols for this part. We can see that the device is built with a column of transceiver blocks on the left and general-purpose I/O banks in the middle and right columns. We can also see from the yellow highlight that I/O bank 2L is special because it can handle 3-volt signals. The transceiver locations are shown on another web page where we can see the 1D bank is above the 1C bank. Not shown are the collection of dedicated configuration pins, pins to provide an analog input measurement function, and the many classes of power pins on the device. Since we are using the Altera physical flow, we will build the symbols using the column layout of the pins in their bank locations. It is instructive to view the finished symbols to show what we are aiming for. We created one symbol to contain the transceiver pins, their reference clocks, and power and support pins. We created one symbol for the 3-volt 2L I/O bank, one symbol with the I/O bank 2K and 2J pins, and then one symbol for the 2A and 3A I/O banks. The I/O bank symbols also contain the BCC I/O power pins and the VREF input pins for the corresponding banks. We create another symbol for the configuration and ADC pins, another for the core power pins, two symbols for the ground pins, and a symbol for the no connect pins. Using the SDL symbol description language with Part Builder, it is a trivial task to reorganize sets of pins into different symbols. For instance, if a user wanted to create the I/O pin, power pins, and transceiver pins in a separate symbol, it would take a matter of minutes to reorganize the SDL code. We start Part Builder, select the New Part button to start working on a new part. The Create New Part menu will pop up. We select C CAD Enhance Work Dir/New Part Test for the working dir entry. We enter 10AX016E3F27E2SG in the part name entry. We press the Create New button and are prompted to save the SIMGen controlled text file in the new directory that will be created for us to build the part in. We press Save, return to the Create New Part directory, and select Done. Now we are ready to start configuring the build process. We can see that the part name has been set to the 10AX016 in the main GUI. We set the pin report type to Altera Physical. For this flow, we need a special package file available for download on the Altera Intel website, which describes the pins of the part. We will use this as the pin report file. The file is named 10AX160.txt. This pin file contains the pins for all 3 of the packages that Altera offers for the GX160 part. We use the Browse button to pop up a file browser to locate where it is downloaded. We use the History Cache pull-down next to the file name entry to find it quickly since we accessed it before. We then hit Open, and Part Builder will offer to make a copy of the file for us in the local working directory. We accept that. Because we are using the Altera physical flow, we need to provide 2 more configuration items, the Altera family and the Altera package, which we will use to select the proper package in the pins.txt file we downloaded from Altera. We use the More Part Config Settings button to pop up a menu to allow us to configure the settings. We then click the Find Parts Package and Report button. It reads the pins file and determines that this is an Altera A10 family part. It populates the Altera package choices pull-down with the different package codes it found in the pins file. We use the pull-down to select the F27 package, which is the code for the 672-pin package found in the Altera part number. Now we are ready to read the pin report file. We go back to the main GUI and select the Read Pin Report button. Part Builder will read the Altera pins file and determine there are 672 pins in the device. If we haven't set the num pins field yet, it will offer to set that for us, and we accept. It is worth a few words here to describe what Part Builder does when it reads the Altera pins.txt file. It extracts data for all the pin locations in the selected package and builds its own unique bank base name for each pin that help capture the position of its pin in the bank and what special functions might also be assigned to it. We quickly look at the Pin Explorer here to see some of the pin names that were extracted. The SmartFrac feature is automatically run after reading the pins. The names that Part Builder created for the Altera pins are designed to be easily recognized by SmartFrac, whose purpose is to do as much upfront work as possible to organize the pins into functional blocks for the user. SmartFrac creates the first pass of the symbol description language, or SDL file, splitting pins into two categories, signals and power. We can see from the SmartFrac status that it recognized that this is an FPGA device and it has 5 I/O banks and 2 transceiver banks. It found 36 pin match statements required to place 329 signal pins and 31 power match statements required to place the remaining 343 power pins. We will now open the SDL editor to organize the SmartFrac generated SDL into multiple symbols. We select the Open SDL Editor button and a pop-up asks us if we want to use the SDL template file it created, since no symbol description file has been selected. We accept this offer and Part Builder opens the SDL editor with the newly created file loaded and ready to edit. Let's take a quick look at the SDL that SmartFrac created. It creates a template and puts all the pin matches for the signal pins surrounded by a start of symbol and end of symbol directive, named signal symbol 1, and then another symbol for the power pins. There are very few pin matches we need to organize because the FPGA pin naming structure is so regular. One pin match can match all the I/O pins in one bank. For instance, the pin match IOP.**2A is a regular expression that matches all the pin names in the 2A I/O bank except the VREF pin. There is another pin match VREF N028 to capture that pin. For the transceiver pins, SmartFrac detected that there were groups of input and output diff pairs and in 6-bit buses, so it created several matches to capture them and automatically places the P/N pin pairs together. All 185 ground pins are matched by the ground pin match. All 49 VCC pins are matched by the VCC pin match. SmartFrac and the intelligent pattern matching supported by SDL makes easy work of setting the location of whole groups of pins into sets of symbols. To keep this demo at a reasonable length, we will describe the SDL editor process here, but skip showing all the steps to create it. The job for the SDL editor is to place each pin match between a symbol start and symbol end directive, provide a name for each symbol we add, choose a side for each pin match, and add spacers or balanced symbol side directives to get clean-looking symbols. A companion video on this site recorded the full process showing how we use the Part Builder SDL editor to create this final symbol order.sdl file. It creates the transceiver symbol with the 1D pins followed by the 1C pins, the 3 I/O bank symbols for banks 2L, 2K with 2J, and 2A with 3A, the config bank symbol, the core power symbol, the ground symbols, and the no connect symbols. The config and power blocks for an Altera FPGA are very similar for the whole device family, so once we create the SDL to describe those symbols, that SDL portion can be reused to create another device in the same family, making the job so much easier when we build the next part. The GX100 device only contains 5 GPIO banks. There were only 3 symbols required to fit all the GPIO banks, so it wasn't too difficult to move the pins around in the SDL editor. If there were more I/O banks like in the GX900 or GX1100 devices, which contain some combination of up to 16 I/O banks and 16 transceiver banks, we would have wanted to use the power of SDL loops to create all the I/O banks, using one symbol directive with pin match statements wrapped in a loop construct, where the bank numbers get substituted using the loop variables. Looping provides a very easy way to get a consistent looking set of symbols, and when you want to tweak the spacing between pins, you only have to tweak one instance, and the loop applies your tweaks to all of the symbols. It takes the same amount of time to create a part with 5 I/O banks as it does to create the part with 16 with loops. The example design for this part, available for download from CAD Enhance, includes this SDL file where I/O banks were created using loops. Now we are ready to build the symbols. We use the Save As button to save the SDL file. We name it symbolorder.sdl and accept when Part Builder asks us if we want to change the SDL file setting to this newly named file. Then we use the green arrow on top right side of the SDL editor to start the part building process. Part Builder will report any problems it sees in the SDL, including if we forgot to change one of the choose side locations to a right or left location. If the SDL is error-free, the symbols for the part should be created, and the status window will show us what Part Builder is up to at each step along the way. Now we can view the symbols we created using the View Symbol button on the main GUI to verify things look the way we want. We could take a look at each symbol and go back and add balance or spacer directives, reorder pins within the symbol using the SDL editor, and rerunning the Create Symbol step. We can also reorganize, moving pins to new symbols or combining pins into an existing symbol. The SDL is stored so that we can rerun the Create Symbol process as many times as we like to get the symbols to look exactly the way we want. Thanks for watching. I hope this demo helped you understand how easy it is to build professional-looking symbols for FPGA devices in Part Builder. It's important to note that the efficiency of SDL is not limited to FPGAs. It can be applied to easily build symbols for any kind of electronic device, large or small. You can check out other video demos on this website for more examples.